Looking at solar insolation and what happens with it, this brings us to a really kind of amazing slide um, where, on one hand, we just review the first point is that incoming solar radiation is absorbed by the Earth. Some is, and the rest is reflected. And we looked at the numbers already, about 31% and 69%, respectively. But really, the theme of this slide is point two, and that is the presentation of a really amazing fact after stating the principle. And that is, okay, long wave radiation absorbed by greenhouse gases keeps the Earth warm, okay? And we call that the greenhouse gases. So without greenhouse gases, Earth would be much cooler. How cooler? This is an amazing number, 59 degrees Fahrenheit. Think for a moment, planet Earth, if it were 59 degrees cooler. That's just really hard to imagine. So greenhouse gases are our friend. They make us the kind of Goldilocks planet, right? Not too hot, not too cold, just about right. And without them, as we think of, we wouldn't know Earth as it is today. There would still be probably a little life on it in equatorial regions, but nothing at all like what we have today. So going back in time, that relationship between greenhouse gases and temperature is very robust. The graph at the bottom shows just how strong that relationship is. As carbon dioxide rises, temperature rises. And when carbon dioxide falls, temperature falls. The connection between them is complex. There is some feedback process going on there, but there's really little doubt that there's a strong association between the two, looking at 800,000 years of data. Wow. How could we know that? How could we know what the temperatures were going so far back in time? So going back to the scientific model again of research, observation, explanation, prediction. This, to a large degree, is just about observation. But how do we observe the past? These graphs are put together by looking at ice cores. What happens is on continental glaciers, in this case it's Antarctica, there are each year there is a summer when there's a little bit of a melt period with the sun out and it's a little warmer at times, and the winter when it's cold. So each year there's a layer of snow. So there's this whole layer, and you can, if you just kind of dig through ice sheets going from top to bottom, you start with this year, and then the one below that is, hey, guess what? Next year, and then the one below that is 2 years ago, and so on. You just keep going down and down and down and down. These things are thousands of feet thick. Each layer tells a story of that year. There are little bubbles of air that were trapped in each of those layers. And those bubbles, from those, we can use very sensitive and precise instruments to measure the amount of carbon dioxide in the atmosphere at that time. And we can also get a proxy of temperature by looking at the oxygen isotopic analysis. And we're later going to find out what isotopes are. If you haven't, don't remember that maybe from your science that maybe you had in high school. But basically the ratio between two of the key oxygen isotopes gives us a very close proxy for what the temperature was in the atmosphere at that time. So we've got this amazing record going back. And we're later going to have a visit with Richard Alley, the Penn State geologist who does this kind of work.